Welcome everyone to our online NPTEL course Environmental Chemistry and Microbiology. This course will be taught by Professor Sudha Goel and myself Anjali Pal. We are both from Civil Engineering Department of IIT Kharagpur. We have divided this course into two parts. The first part, environmental chemistry, will be covered by me, and the second part, environmental microbiology, will be taught by Professor Sudha Goel. The objective of this environmental chemistry is shown. Student will be able to apply basic principles of chemistry. The course will be covered by the following topics: acids, bases and salts, chemical equilibria, chemical kinetics, chlorination, nitrogen chemistry and nuclear chemistry. So, in my first lecture I will start with acids, bases and salts. The old concept of acids is that some people told that acid should turn blue litmus red, somebody told it is sour, and some people told that it reacts with bases to form salt and water. It burns the skin, it can donate proton, but all these properties were very old and it is not explained by the modern concepts. The first modern concept was given by Arrhenius, and he said that the acid is something which gives hydrogen ions in water solution, and a base is something which gives hydroxide compound, and the neutralization process is nothing but the union of H plus and OH minus to form the water. This is also called water and concept, and it was first given by Arrhenius in his dissertation, PhD dissertation, and he explained it as electrolytic dissociation theory in 1887. But this theory has several limitations. Say for example, we all know now that proton H plus cannot stay as such because of its high hydration energy. It immediately combines with the water molecule to form H3O plus, which is oxonium ion. It is also called hydroxonium ion, and also it can be called as hydronium ion. Second thing is that in this concept it is mentioned that acid is a proton donor in aqueous solution, that means water medium, and base is something which gives the hydroxide ion in water. But an acid should be defined not in terms of any medium, but it should be told by itself. Say for example, in gaseous phase or in other solvents, what happens for acids and what happens for bases. It also could not explain the properties of ammonium ion, which shows an acidic property, and acetate ion is basic, showing basic property. So, this has some limitations, but at that time it was quite sufficient, and in aqueous medium it is quite good to explain the acidic and basic properties. It is very important to know the ion product, which is the ion product of water. We all know that water dissociates into H plus and OH minus. Of course, H plus cannot stay as such it immediately combines with water to form hydroxonium ions. So, in terms of the formation of hydroxonium ions, we can tell that this is the actual equation for water dissociation. Water dissociates very slightly, and the ion product of water, which is called as Kw, which is nothing but the equilibrium constant of this equation. It is nothing but H plus ion concentration into OH minus ion concentration by water concentration, and because this is unity. So, we can tell it is nothing but H plus ion concentration into OH minus ion concentration, and this is called as the ionic product of water. It is nothing but the equilibrium constant of the dissociation of water molecule. Now, this concept which Arrhenius told in aqueous medium, it was then extended by Franklin in 1905. He extended this theory in another solvent, which is liquid ammonia. We know that in liquid ammonia many reactions is carried out, and he said that just like water molecules, ammonia also can give ammonium ion and amide ion. So, this is the cationic part and this is the anionic part, and he said very similar, it is very similar to the Arrhenius concept. He said that something in liquid ammonia which gives ammonium ion is an acid and which gives amide ion is a base. But remember that this is extended in liquid ammonia, and he could explain many things. Say for example, HCl we know that acts as an acid in water, and ammonium chloride acts as an acid very similar way in liquid ammonia. So, HCl gives H plus ion in water medium, that is why it is an acid in water, and ammonium chloride in liquid ammonia gives NH4 plus. So, it is an acid. So, it is very similar, and if we extend this thing in terms of the acid base reaction, we know that in aqueous condition we know that HCl and NaOH, we all know that it gives salt and water. Similarly, ammonium chloride and sodium amide, so it gives NaCl and NH3. So, these types of reaction could be explained by Franklin very nicely. Also, we know that ammonia, as we have seen that ammonia is a protonic solvent, but there are some solvents we know that it is non-protonic. Say for example, liquid sulfur dioxide. In liquid sulfur dioxide we do not have any proton. So, what will happen to this? It is also explained by Franklin. So, something which gives the cationic part of sulfur dioxide, that is thionyl group, that will be an acid, and something which will give in liquid sulfur dioxide the sulphite ion, that is nothing but SO3 minus 2, that will be called as a base. The limitations of this theory, the Franklin theory, is that the acid base phenomena in solvent system only it has been explained here, just similar to Arrhenius concept. So, it is placing undue stress upon the ionization of solvent, and also it excludes the non-ionizing solvent, and in absence of any solvent, say for example, in gaseous phase, it could not explain the properties of acids and bases. The theory defines acids and bases in terms of their solutions and not in terms of the properties of the substance themselves, and it places undue stress upon the ionic character of neutralization also. So, every theory has some limitations, but that time it could explain the properties of acids and bases very nicely in some other solvents, but not in water. Now comes the Lorry-Bronsted theory, and it has been stated in 1923 that an acid is a proton donor and a base is a substance that is capable of combining with a proton. That means, here it is not told that that base is a substance which can give OH minus. Instead, it said that base is something which can take up the proton. So, here it is shown, you can see that acid, if I denote it as A and base I can say it is B, then acid gives H plus, then H plus will be taken up by the base to form some type of acid. So, this is more general, and this can explain many things beyond this Arrhenius and Franklin concept. Say for example, by this Bronsted theory we can explain several molecules. Say for example, if it is a neutral molecule HCl, then we can explain why it is an acid. If it is a cation, say for example, ammonium ion or hydronium ion or even some aqueous complexes of aluminum, then also we can explain that why it is an acid, or even some anions like bisulfate or bicarbonate, that also can be explained. Why? Because you know this bisulfate can give proton, bicarbonate can give proton, so it is an acid. Ammonium ion can give proton, hydronium ion can give proton, so it is an acid. Now, similarly, in case of base, say for example, neutral molecule NH3, it can take up a proton to form ammonium ion, so it is a base. An anion, say for example, OH minus, it can take up a proton to form the water molecule, so it is a base. Even a cation, say for example, this type of complexes which can take up a proton to give back this one, you can see here. So, this property also can be explained by this Bronsted-Lowry theory. It has been shown here in equation form that why something is acid, why something is a base. Now, from this we can easily understand that every acid therefore has its conjugate base. When an acid gives up a proton, then it forms another compound which is nothing but its conjugate base. So, it is formed by the loss of a proton, and every base has its conjugate acid formed by the acceptance of a proton. So, it is also called conjugate acid base theory. Now, this theory is very nice in terms of that it can explain many molecules or ions why it is an acid or it is a base. So, here you can see, since a bare proton cannot exist in solution, so no acid base reaction can take place unless there is a base. So, why? Because some acid will give up some proton, but there must be some taker of that proton. So, it is nothing a base. So, because proton cannot exist in solution, it must be combined with something to form something. So, who will take up this thing? A base will take up this thing. So, here it is shown that acid 1 gives a base 1. So, acid 1 gives proton to form its conjugate base, and the base, another base should be there which can take up a proton to form acid. So, acid 1, if we add these two equations, then we will see acid 1 plus base 2 gives acid 2 plus base 1. Thus, an acid reacts with a base to form a new acid and a new base, that is, an acid base reaction involves two conjugate pairs of acids and bases. Here the example you see acetic acid which is acid 1, then the ammonia molecule which is base 2 can can produce ammonium ion. So, this acetic acid gives the proton which is taken up by the ammonia to form the ammonium ion, and then this one is converted to base, which is nothing but the acetate ion. Okay. So, acid 1 and base 1 and base 2 and acid 2, these are the two pairs. So, in this way we can explain all reactions, and we also know that water is amphoteric. So, water can act both as an acid and a base. When it acts as an acid, its conjugate base is OH minus ion. When it acts as a base, its conjugate acid is hydronium ion. This is very simple. Now, here it is shown water functions as an acid here. So, it will give a proton and ammonia will be a base. So, it takes up ammonium ion. So, from water OH minus ion is produced, and from ammonia ammonium ion is produced. Water can function as a base. In this reaction you can see that because HCl is stronger acid than water, that is why. So, everything is relative, you know, you have to think who is better acid, who is better base, then only you can decide that who will act as an acid and who will act as a base. There is a profound effect which tells us that solvent has enormous effect to decide which will be an acid and which will be a base. That means, the acid base behavior of a solute. The very good example of this one, this is the perchloric acid. In the perchloric acid, liquid perchloric acid, if you put HF, hydrofluoric acid, then who will be the acid and who will be the base? That will be decided by the who is better, who is stronger acid. Okay. Here you can tell in this reaction the perchloric acid will be acting as the acid and hydrofluoric acid will be acting as a base. But in this case, where perchloric acid is not there, but nitric acid is there, it will be opposite. That means, nitric acid will be a base and hydrofluoric acid will be an acid. And similar way, neutralization according to Bronsted concept is simply a transfer of a proton from an acid to a base, okay, which has been explained already. Now, all anions are evidently bases, and since they can add protons, anions can add protons, so they must be a base. The strength of a base is a measure of its capacity to capture protons in competition of other bases. As for example, in water solution, OH minus ion is a stronger base, acetate ion is fairly strong, while the nitrate and chloride are very weak bases. In real sense also, in real field also, we know that OH is a very strong base, acetate ion though it is basic, but it is not that strong as OH minus, and nitrate and chloride are very weak bases. Now, Bronsted theory defines acids and bases in terms of the substance themselves and not in terms of their ionization in solution. This is the positive point of Bronsted theory. And though admittedly superior to the theory of solvent systems, but still it has some limitation. Every theory has some limitation. We all know that. What is the limitation? Though most common acids are protonic in nature, but many are not. Say for example, aluminum chloride, we know that it is acidic, but how it can be explained in terms of Bronsted theory? It is not possible. And stannic chloride, it is also acidic. So, how it can be explained by Bronsted theory? So, these are the limitations for Bronsted theory. Now comes the Lewis theory. Lewis theory also given in 1923, where G. N. Lewis proposed a new definitions of acids and bases. This is very simple, and according to this theory, it is told that the base is something which can donate an electron pair, and acid is something which is capable of accepting an electron. So, it is based on electron, something which accepts electron, it is an acid which can give electron, that is called a base. So, considering this theory, the bond formation in the bond formation, Lewis base is a substance that contains a pair of electrons. If it does not contain an electron pair, then how it can give an electron pair, and the base is something which contains the base can have a pair of electrons which can be donated, and acid is something which can take up that electron pair to form a bond, and neutralization is nothing but the formation of the coordinate bond. So, electron pair is given and somebody is taking that electron pair, that is nothing but the coordinate bond, and between the Lewis acid and Lewis base, it is the formation of a bond, coordinate bond between Lewis base and Lewis acid. So, here you can see that ammonia can combine with H plus proton to form ammonium ion. So, this is nothing but the coordinate bond formation. Similar way, copper 2 plus, copper ion can combine, can form a complex with ammonia molecules to form cupramine complex CuNH3 whole 4 2 plus. This is also some type of bond formation, and this can be explained very nicely by the Lewis theory. Now, this is the last one, this is the most general, but this can explain maybe everything, which is nothing but Ushanovich theory. According to this theory, an acid is a substance which can give up cations, can combine with an anion and even with an electron, or it can neutralize a base to give a salt. On the other hand, a base is a substance which can give up anions or electrons, can combine with cations, or it can neutralize an acid to produce a salt. This theory includes all previous acid base definitions, but it is too general. It is too general. Thus, in the first lecture we have discussed that to define an acid or a base, several theories have been considered. Some have some advantage, some limitations, but each one is good and each theory is correct as far as it goes. However, no single concept may be found adequate under all circumstances. Each concept has its own values and limitations, and you have to decide which one you will use to explain the things, to acidity, acidic property or basic property, but you have to remember the solvent, what solvent you are using to explain your things. Thank you. Thank you.